Example 3, use the Gauss-Jordan method to solve the system. First thing we'd want to do is put it in standard form. So subtract the y over. Also subtract this z over. And then the last one's fine. From standard form, we want to change it into an augmented matrix. So let's get rid of this. Augmented matrix just means take out all the variables, basically. Look at the coefficients. 1, -1, 5 equals -6, 3, 3, -1, 10, 1, 3, 2, 5. There's our augmented matrix. Now, where we're going is we want numbers along the main diagonal. Specifically, we want ones, but we'll get numbers first. Everything else on that left side needs to be zeros. So we're going to zero out this 3 and this 1, but we have to use the number on the diagonal. We have to use this 1. So that's where our rules come in. So to get rid of that 3, I'm going to go row 2 minus 3 row 1s. Now again, I have to use this number right here. So if I do row 2, that's going to be a 3 minus 3 of those 1s, that's going to be 0. 3 minus 3 is 0. That's what I want. The top row you can leave alone. But that middle row, we're going to use our rules. So row 2 is a 3 minus 3 of those 1s. That is 0. And row 2 is a 3 minus 3 negative 1s. That's going to be 3 plus 3 is 6. And row 2 is -1 minus, that's going to be 15. 3 times 5 is -16. And row 2 is a 10 minus 3 times -6. That's going to be 10 plus 18 is 28. Now we need to get rid of this 1 right here. We need to zero that out. Using the 1 in the circle, looks like you can just subtract. So I do row 3 minus row 1. So 1 minus 1 is 0. And let's change colors here. So we did 1 minus 1 was 0. And 3 minus -1 is 4. 2 minus 5 is -3. And 5 minus -6, that's plus 6, that'd be 11. So we have a new matrix, it's closer to what we want. Remember where we're going. We want numbers along this main diagonal and zeros elsewhere. So next I'm going to look at the y column, and I'm going to use this 6 to zero out the other numbers. Okay, so if I was going to zero out this -1 right here, I'd go through the LCM. The LCM of 1 and 6 is 6. I want a statement that says something like 6 minus 6 equals 0 or -6 plus 6, one way or the other. So I'm going to do 6 row 1s plus row 2. That would give me -6 plus 6 is 0, right where I want it. So do that all the way across. 6 row 1s is 6 plus row 2. That's 6 plus 0 is 6. 6 of these is -6 plus 6 is 0. 6 of these is 30 plus -16 is 14. 6 of these is -36 plus 28 is -8. Now, the middle row, we don't really need to change, but one thing that I can do if I want to is reduce, because all of those numbers are divisible by 2. So I'm just going to divide them all by 2, or multiply by 1/2 if you'd rather think of it that way. So take half of all of those just to kind of reduce. Now I'm looking at that 4. So you see the 4, we have to get rid of the 4, but we have to use this 6. So you get a common multiple, probably either 12 or 24. I would use 12. 12 minus 12 is 0. So I'm going to do 3 of these is 12, so 3 row 3s. And I'm going to subtract 2 of these 6s, 2 row 2s. That would give me 12 minus 12. So 3 zeros minus 2 zeros is still going to be 0. 3 4s is 12, minus 2 6s is 12. 12 minus 12 is 0. 3 of these is negative 9. Minus 2 of these, that's going to be plus 32. So we have negative 9 plus 32 is 23. And then we have 3 of these is 33. Minus 2 of these is going to be minus 56. 33 minus 56 is negative 23. So again, keep in mind where you're going. We want numbers along these main diagonals. We'll change them to ones later, but for right now, just as long as they're numbers, that's fine. But I tell you what I'm going to do first. Okay, those 23s are going to be hard to deal with. So what I'm going to do is I'm just going to divide by 23 right here. 0, 0, 1, negative 1. And I'm just going to reduce that row right now because it's going to be a lot easier for me to work with that 1 than with a 23. So I have to use this 1 to zero out these two numbers. That's what I'm trying to do here. So for the 14, let's just go row 1 minus 14 row 3s. That should do it. So let's use that rule right there. Row 1 is a 6. Minus 14 zeros is still 6. And row 1 is a 0. Minus 14 zeros is 0. 14 minus 14 of those is going to be 0. Row 1 is negative 8. Minus 14 negative 1s, that's going to be plus 14. Negative 8 plus 14 is 6. Okay. Now we look in the middle row. Middle row. I need to get rid of the negative 8 using a 1. So my rule might be row 2 plus 8 row 3s. That would be negative 8 plus 8. So do it all the way across. 0 plus 8 zeros is still 0. And 3 plus 8 zeros is still 3. Negative 8 plus 8 ones is 0. 14 plus 8 negative ones, that's going to be 14 minus 8 is 6. And then the bottom row is all good, so just leave it alone. Now, once you've got numbers along the diagonal and zeros elsewhere, it's easy to see what the numbers are because you can just reduce. You can just reduce each of those rows. And remember, this is the X column, the Y column, and the Z column. So if you think about that top row, the top equation is 6x equals 6. You can see that x equals 1 right there. But let's go ahead and reduce it. We can divide that row by 6, and we would get 1, 0, 0, 1. That says x equals 1 right there. The middle row, I'm going to divide by 3. And I get 0, 1, 0, 2. I just divided everything by 3 there. Bottom row, leave it alone. It's already reduced. So really what we want in this Gauss-Jordan is we want this. All right, this is our final matrix. This is what we want. We want ones along that main diagonal and zeros elsewhere. But once we're there, it's easy to see. The top row says x equals 1. The middle row says y equals 2. And the bottom row says z equals negative 1. That's your solution.